Have you ever stopped and pondered just how vast the universe truly is? Today, we're setting out on an incredible journey, one that will take us from the infinitesimally small to the mind-bogglingly large. We'll traverse through the unseen world of subatomic particles, scale up to the human level, ascend further to our solar system, and finally, soar into the cosmic expanse of galaxies and the universe itself. So, buckle up your mental seatbelts because let's embark on this journey together, starting from the smallest known measurements in our universe. In the realm of the incredibly small, we start our journey. To truly grasp the immensity of the universe, we must first explore the smallest dimensions that we know of. Let's begin with the Planck length, the smallest length that has any meaning in physics. It's unimaginably tiny, over 1,000,000 billion times smaller than a single millimeter. From the Planck length, we move to the realm of the subatomic, where particles like quarks reside. Quarks are the building blocks of protons and neutrons, which themselves are components of atoms. To give you a sense of scale, if a proton were the size of a marble, a quark would be as small as a speck of dust. Yet, these infinitesimal particles are the foundation of everything we see and touch. From these tiny measurements, we move up to the scale of atoms. Prepare for a leap, because although these particles are minute in comparison to the vastness of the universe, we're still in the realm of the tiny. Atoms, the building blocks of matter, are our next stop. Imagine a sphere, tiny, isn't it? But packed within this minuscule entity are subatomic particles we discussed earlier. The size of an atom is about 1/10,000,000th of a millimeter. That's around 100,000 times larger than a proton. Now, atoms band together forming molecules. A molecule of water, for instance, is made up of 2 hydrogen atoms and 1 oxygen atom. These molecules are still incredibly small, yet they're about 1,000 times larger than individual atoms. To give you a sense of scale, if an atom were as big as a football stadium, the nucleus, the part that contains the protons and neutrons, would only be the size of a pea in the center of the field. So you see, we've traveled from the subatomic world to the atomic and molecular realm, each step unveiling a new layer of the universe's immense complexity. Now let's zoom out a bit more to the scale of humans and our immediate surroundings. We live in a world that feels enormous to us, yet in the grand scheme of things, it's still incredibly small. It's fascinating to realize how we, as human beings, fit into this picture. An average human stands about 5 feet 8 inches tall. A skyscraper like the Empire State Building is about 440 times taller than that. Yet even the largest man-made structure pales in comparison to the natural wonders of our world. Mount Everest, the highest peak on Earth, is almost 29,000 feet high, and this towering giant is merely a bump on the face of our planet, which itself measures over 7,900 miles in diameter. But when we consider the size of the Earth in relation to the cosmos, we begin to grasp just how small we truly are. Our planet, our home, is just a tiny speck in the vastness of our solar system. Our solar system, home to our small blue planet, is where we venture next. Imagine, if you will, a cosmic neighborhood, where Earth is just one house on the block. This block extends over 2 billion miles, from the blazing ball of gas we call the Sun, to the icy outskirts where Neptune, the furthest planet in our solar system, resides. In this neighborhood, our Earth is a modest dwelling, dwarfed by the gas giants Jupiter and Saturn. Even Mars, our close neighbor, is just half our size. Yet despite these differences, each planet orbits the Sun, bound by the invisible strings of gravity. And then there's the Sun, a fiery sphere over 100 times larger than Earth. It's so big you could fit 1,000,000 Earths inside it. Its gravity holds our solar system together, like a cosmic glue. Beyond our solar system, we enter the realm of the Milky Way galaxy. Our galaxy, one among billions, is an enormous cosmic city of stars. Enter the Milky Way galaxy, our very own celestial neighborhood. This majestic spiraling disk of stars, dust and gas stretches an astounding 100,000 light-years across. Yes, you heard it right. That's the kind of distance light, the fastest thing in the universe, would cover in 100,000 years. Now think about this. Our solar system, vast as it is just a tiny speck in one of the galaxy's spiral arms. We're situated about 26,000 light-years from the galactic center, a bustling hub of astronomical activity. Here, stars are densely packed, and a supermassive black hole named Sagittarius A star reigns supreme. The Milky Way is not alone. It is but one among billions of galaxies scattered across the cosmos. Some are smaller, dwarf galaxies, while others are far more massive, like our neighboring Andromeda galaxy, which is on a collision course with us, set to merge in about 4 billion years. But even as we marvel at our galaxy's scale, it's important to remember that the Milky Way is part of a larger cosmic structure. Galaxies are not randomly distributed. They group together in clusters and superclusters. Our Milky Way, along with Andromeda and about 54 other galaxies, forms the local group. Beyond that, the local group is a small part of the Virgo supercluster, which in turn is part of the even larger Laniakea supercluster. It's mind-boggling, isn't it? To think that our entire galaxy, with its hundreds of billions of stars, is just a minor player in this cosmic drama. The scale of the universe is indeed humbling, reminding us of our smallness and yet our unique place within this grand cosmic tapestry. Yet, even our galaxy is dwarfed by the scale of the universe itself. Finally, we reach the grand scale of the universe itself. If you thought the galactic scale was impressive, brace yourself for a journey through the expanses of the universe. Trying to grasp the size of the universe is like attempting to understand infinity. It's beyond our human comprehension, but let's give it a shot. Imagine this: if you could travel at the speed of light, it would take you about 46 billion years to reach the edge of what we call the observable universe. That's a sphere with a radius of 46 billion light-years centered around us. But why is it called the observable universe? Well, it's simply because that's the farthest we can see. Now here's a mind-bending concept. The observable universe is not the entire universe. It's just the tiny bit we can observe from our vantage point. The universe beyond that, the unobservable universe, is thought to be infinitely larger. The reason we can't see beyond the observable universe is because of the speed of light and the age of the universe. The universe is about 13.8 billion years old. So, we can only see objects that are 13.8 billion light-years away or closer. Anything farther than that hasn't had time to reach us yet. It's like there's a cosmic horizon beyond which we can't see. And here's another kicker. The universe is expanding. That means distant galaxies are moving away from us. Some are even moving away faster than the speed of light. So, their light will never reach us. It's as if they're disappearing beyond the cosmic horizon. But let's not stop there. What if our universe is not the only one? Welcome to the realm of the multiverse. This is a hypothetical concept suggesting that there could be an infinite number of universes out there, including ours. Each could have different laws of physics, different dimensions, and perhaps even different forms of matter. Imagine an infinite cosmic ocean filled with countless bubbles. Each bubble is a universe, and we're inside one of those bubbles trying to make sense of it all. It's a dizzying thought, isn't it? So, when we ask how big the universe is, the answer is incomprehensibly vast. Our journey from the smallest to the largest scales of the universe has been a truly humbling experience. We've traversed the subatomic realm, where particles like quarks and neutrinos reside. From there, we've zoomed out to the atomic and microscopic scale, where atoms and molecules form the building blocks of everything we see and touch. Further out, we've explored the human scale, reminding us of our place in the grand scheme of things. Our voyage continued to the solar system, our celestial neighborhood dwarfed by the vastness of the galaxy that hosts it. On a galactic scale, we've realized that our Milky Way is but one of billions of galaxies in the observable universe. Finally, we've reached the edge of the known universe, a boundary that is constantly expanding and shrouded in mystery. This journey has shown us the cosmic immensity we're part of. Remember, no matter how small we are in the universe, our curiosity and desire to understand it make us truly significant.